Hello, discrete math fans. We're going to create something called combinatorial circuits. What we'll do is combine several different types of circuits to create a more complicated one. There are a few basic rules for combinatorial circuits. We're never going to combine two input wires. A single input wire can be split partway and used as inputs for two different gates. So you can't combine input wires, but you can split them. An output wire of one gate can be used as the input of another gate. However, you cannot have the output of a gate feed back into the same gate. So you can't create loops. If you're given the input signals for a circuit, you can find its output by tracing through the circuit gate by gate. Let's do an example. Let's take this circuit. It's only got two gates in it and two input variables. And what we'll do is we'll figure out what the output of the circuit is for these inputs. And the specific inputs that we want are P equals 0 and Q equals 1. So if we place a 0 as the input to the NOT gate, the output of the NOT gate will be a 1. Then that gets fed in as one of the inputs into the AND gate. Then we have the other variable, Q, gets fed into the AND gate. So we have both of these ones getting fed into the AND gate, and that gives us an output of 1, since the AND is a 1 if and only if both inputs are 1. So with the input of P equals 0, Q equals 1, we get an output of 1. Let's try one a little more complicated. Here we're going to have input signals P equals 0, Q equals 1, and R equals 1 as inputs into this circuit. So we feed in the 0, 1, and 1, and we see what happens when we follow through here. So the 0 and the 1 get fed into this AND and give us an output of 0, because if either input is 0, then the AND outputs is 0. Then we feed the 0 into the NOT, and that spits out a 1. Now we take a 1 and a 1, input it into an OR. All we need is one of them to be a 1, and we get an output of 1. So with an input of 0, 1, 1, we get an output of 1. Okay, that's all for now.